Welcome to Chapter 3.5, Systems of Equations. And here we're going to learn how to solve a system of linear equations involving two variables. Methods used to solve systems of equations. There's graphing, substitution, and elimination, linear combination. So first we're going to discuss in this part 1, graphing. Graphing is helpful to visualize the three types of solutions that can occur when solving a system of equations. The solution to a system of equations is the points at which the line intersects. In example number 1, we're going to look at graphing these two equations. So let us go over to the whiteboard and see what happens. In this example 1, we're going to look at graphing. And we're going to graph the two equations. And we have two equations, 2x minus y is equal to 2 is one of the equations. And then we're going to graph the other one, x plus y is equal to negative 2. So for the first one, I'll do the table method here. So we have x, our equation, 2x minus y equals 2. And then y, and then we would write our coordinate. So let's say x is equal to 0. That means negative y is equal to 2, and that means y is equal to negative 2. So here we have negative 2, so our coordinate is 0, negative 2. Then for the other, because we need at least 2 points to make a line, and I'll make y is equal to 0 for simplicity. And I have 2x is equal to 2. So x is equal to 1. So here we have 1, and our coordinate is 1, 0. So that's for that line. So it would look something like this. So we have for this one 0, if x is 0, negative 2, and y is negative 2, 1, 2, so negative 2. And that's one of the points. And the other one is if x is 1 and y is 0, so we could maybe draw a line kind of like that for that one. Now for the other one, we can do the same thing. X plus y is equal to negative 2. And then the coordinate. So if we have x is equal to 0, then y is equal to negative 2, so negative 2. So this is 0, negative 2. And similarly, if we make y equal to 0, then x is equal to negative 2, negative 2. And then we end up with the coordinate negative 2, 0. So that means it would be 1, 2, negative 2. And then this is also, they intersect here. So I draw the line, and it's something like that. So we see that the point that both of these lines have in common is 0, negative 2. You also see it's not that easy to draw it, but this worked out very nicely because it intersects at a place not where there's no fraction there or anything that would make it difficult to graph. Reviewing what we did on the whiteboard, but in a slightly different way. Here, I put each equation in terms of the point-slope formula. Y equals mx plus b, where my slope is 2 and my y-intercept is -1. And similarly, I did it for the other equation, where my slope is -1 and my y-intercept is -2. And then we graphed it, and we see where the points intersect is at 0, -2. This is the place where the two equations can be solved with the same coordinate. In example number 2, we have these two equations. In example number 2, we have these two equations. And we're going to solve these two equations using the technique of graphing and see what happens. What I'm going to do in this example is I'm going to put everything in terms of y equals mx plus b, or the slope-intercept formula. So what I do in the first equation is I solve for y, and I get y is equal to -3 over 2x plus 3 over 2. Similarly, I do the same thing for the next equation, and I get y is -3 over 2x minus 2. Notice how they both have the same slope. And remember what we learned earlier about equations that have the same slope. Well, if we graph them, it turns out that they were parallel. And when equations are parallel, that means that they have no solution in common. Also notice that they have the same slope, but their intercepts are different. So in the case of the blue line, the intercept is 3 over 2, but in case of the red line, the y-intercept is -2. In example number 3, we're going to look at these two lines and see what happens. So again, what I'm going to do is solve for y equals mx plus b, or find its slope-intercept formula. So I get, for the first one, y is equal to x plus 3. And then for the second one, I get y is equal to x plus 3. Wow! Look, I get the same formula for both. So if I graph them, they are the same line. Both these equations are essentially the same line. And what this means is that they have infinitely many solutions in common, or one can say all their solutions in common. So if you have a situation where they have the same slope, the same y-intercept, and they're the same equation, this means that they have infinitely many solutions. A word about graphing. Graphing is not the best method to use if an exact solution is needed. Graphing is often a good method to help solve contextual problems. Why is graphing not always a good method? Well, if I was to graph these two lines, can you tell exactly where these two lines intersect? It's a little bit hard because it's not on one of these little boxes. It's sort of inside, kind of hard to tell. With other methods, an exact solution can be obtained. Thank you very much. I hope that you enjoyed this video. Be well, take care, and goodbye for now.